Every year, the world produces nearly 60 million metric tons of electronic waste. That's equivalent to throwing away over 1,000 laptops every second. Now imagine inside those discarded phones, TVs, and computers is a hidden fortune, over $60 billion worth of precious metals. The twist: most of it gets lost forever. But what if we could mine gold from garbage? Welcome to the world of e-waste biomining, where microorganisms do the digging and trash becomes treasure. Let's talk about what happens when your old smartphone dies. Maybe it goes into a drawer. Maybe you drop it off at a recycling point. Or maybe it just vanishes into a black hole of forgotten tech. Multiply that by 8 billion people, and you start to see the problem. Our hunger for technology is insatiable. Every year, we consume more devices, upgrade faster, and generate more waste. According to the Global E-Waste Monitor, e-waste is now the fastest growing solid waste stream on Earth, surpassing even plastics. By 2030, the annual total is expected to reach 74 million metric tons. But where does all this e-waste go? Some ends up in regulated recycling plants, but most of it, nearly 83%, is handled informally or illegally. It gets shipped to poorer countries under the guise of used electronics and ends up in open-air dumps in Ghana, Nigeria, India, and Indonesia. In Agbogbloshie, one of the largest e-waste landfills in the world, children as young as 10 burn wires to retrieve copper. They inhale toxic fumes. Their water is poisoned with lead. Their soil is saturated with mercury. And for what? A few cents worth of scrap metal. The environmental cost is staggering. Cadmium and lead seep into the soil, contaminating crops. Dioxins from burning plastics become airborne, causing respiratory illnesses. Mercury pollutes rivers, disrupting aquatic life and human health. This isn't just a distant problem. It's happening everywhere. In the USA, less than 25% of e-waste is properly recycled. The rest is incinerated, landfilled, or forgotten. But here's the kicker. While we're choking the planet with discarded electronics, we're also throwing away some of the most valuable materials on Earth. Let's open up a smartphone not physically, but chemically. Inside, you'll find gold used in connectors and microchips, silver used in soldering and circuit boards, copper in wires and motors, palladium in capacitors, cobalt and lithium in batteries. Here's a wild fact. Mining 1 ton of gold ore yields about 5 grams of gold, but processing 1 ton of e-waste, that can yield up to 300 grams of gold, 60 times more than mining the same weight of rock. In Japan, the city of Akita recycled enough e-waste to extract the gold medals used for the Tokyo 2020 Olympics. That's how much value is being ignored in landfills every day. If we recovered even half of the materials in global e-waste, we'd offset the need for mining new metals. We'd reduce the carbon footprint, avoid toxic runoff, and save billions in extraction costs. But how do we get these metals out efficiently, safely, and affordably? That's where biomining enters the story. Traditional mining is messy. It involves blasting rocks, using harsh chemicals, and leaving behind massive ecological scars. The mining industry is responsible for up to 7% of global carbon emissions and causes more than 50% of environmental conflicts worldwide. Enter urban mining, the concept of recovering raw materials from existing products and waste in urban environments. Now, take that a step further: biomining. Biomining uses microorganisms such as bacteria and fungi to extract metals from ores or waste. In the natural world, some microbes feed on metal ions. They literally dissolve metals like gold, copper, and nickel from rocks or electronic waste. For example, The bacterium Acidothiobasilus ferrooxidans is used to oxidize metal sulfides, releasing metals like copper and iron. Fungi like Aspergillus niger can leach out rare earth elements by producing organic acids. In labs, researchers are now optimizing these biological tools to target electronic waste. It's called bioleaching, a low-cost, low-energy, environmentally friendly technique to mine from our trash. Imagine a vat of crushed electronics. Add bacteria. Let them work for a few days. Filter the solution. Recover your metals. No cyanide. No acid baths. Just biology doing chemistry. This isn't science fiction. It's already happening. Let's start with Mint Innovation, a startup in Auckland, New Zealand. Their secret? A proprietary process that uses non-toxic chemicals and engineered microbes to extract gold and copper from circuit boards. Here's how it works. 1. Devices are shredded into powder. 2. The material is passed through a solution containing special bacteria. 3. These microbes latch onto metals and leach them into the solution. 4. The metals are then recovered via electroplating or precipitation. They claim to extract over $10,000 worth of metals per ton of e-waste, all without harming the environment. Their pilot plant proved so successful that they're expanding into Europe and Australia. Next, look at TES, a global company based in Singapore. In 2022, TES processed over 100,000 metric tons of e-waste across their facilities, extracting and refining metals, plastics, and components. But they're going a step further. Rather than just recover materials, they refurbish and remanufacture entire devices, extending the life of electronics and reducing the need for new production. In India, the National Metallurgical Laboratory has developed microbial processes to recover metals from discarded computer parts. Their goal: build micro-recovery labs in urban areas, offering jobs and sustainability together. And it's not just startups. Major tech giants are joining the race. Apple has its own disassembly robot, Daisy, which can take apart 200 iPhones per hour and sort out valuable components. Dell and HP are investing in closed-loop recycling systems, where plastics and metals from old devices are used to build new ones. These aren't gimmicks, they're glimpses into the future. Globally, the value of raw materials in e-waste was estimated at over $62.5 billion in 2022, more than the GDP of many small countries. Gold alone accounts for about 10% of that total. Add silver, copper, palladium, and rare earths, and the numbers become staggering. But here's the problem. Most of that value is not being recovered. Why? Lack of infrastructure, limited awareness, informal recycling sectors with poor safety and efficiency, and outdated policies. Imagine if countries invested in biomining centers, trained workers in safe waste handling, and set up buyback systems for old electronics. We could reduce dependence on traditional mining, cut greenhouse gas emissions, and create millions of green jobs worldwide. In fact, the International Labor Organization predicts that recycling and circular economy industries could create over 6 million jobs by 2030 if proper investments are made. What's coming next? Researchers are now engineering synthetic bacteria to be more selective and efficient at binding specific metals. Others are exploring enzymatic extraction, where enzymes digest polymer casings and free up embedded metals. A team at University of California, Berkeley has even developed a metal-hungry yeast that can separate rare earth elements from e-waste using biofilters. Meanwhile, DARPA, the USA Defense Advanced Research Projects Agency, is funding research into microbial mining on the Moon and Mars. If we can't afford to pollute Earth further, maybe we can send our microbes to space. E-waste isn't just a problem. It's a solution in disguise. It's a gold mine hidden not in the mountains, but in your old phone drawer. And with biomining and urban recycling, we're learning to tap into this modern treasure without destroying the planet.